Okay, so example 2 on the gas stoic note. What volume of carbon dioxide at 65 degrees Celsius and 103.5 kilopascals can be produced from the decay of 20.85 grams of baking soda? Baking soda decomposes according to the following equation. So if I look at this question here, I already have the equation given to me, but it isn't balanced. So let's just add a 2 out here in front of our baking soda. And now we're all balanced up here. Okay, so again, I need to figure out the the volume of carbon dioxide. That's the end result that I'm looking for. So let's just write out all of our givens that I have here. The temperature I know is 65 degrees Celsius. However, that will never do because it's in degrees Celsius, so I need to add 273 to get it into degrees Kelvin. So 338 Kelvin. I also know that the pressure is 103.5, and that's in kilopascals, so that's good. I need to know the R value. That's my gas constant, so I have that. 8.314 kilopascals liter per mole Kelvin. And of course I would need to have the actual moles of this one. If I look at this question, I unfortunately don't know the number of moles that I have here yet. So I need to look back at the question and see if there's anything that I can solve for first. So the first step here is actually going to be figuring out what are the number of moles of baking soda that I have, and then I can use my molar ratio between baking soda, this sodium bicarbonate, and carbon dioxide. That will give me the moles of carbon dioxide, and then I can use the ideal gas law in the end in order to solve for the volume of carbon dioxide that I have there. So if I look at this question, I have the mass of baking soda is 20.85 grams. I can use my periodic table to figure out that the molar mass of my baking soda is 84.01 grams per mole. And then I can use my equation, moles equals mass over molar mass, in order to solve for the number of moles. So 20.85 grams over 84.01 grams per mole. So therefore I have 0.248 moles of sodium bicarbonate. So again, the goal of this question is to solve for the volume of carbon dioxide. So my second step here, that was my first step, was solving for the number of moles. My second step is going to be using my molar ratio to compare between sodium bicarbonate and carbon dioxide. So NaHCO3 to CO2. So I see that this is a 2-to-1 ratio. So if I have 0.248 moles, I can solve for the number of moles of carbon dioxide by cross-multiplying this. So 2x equals 0.248. Divide that by 2, it's a half a ratio. So if I look at this, I have 0.124 moles of carbon dioxide. So let's just plug that in up here. So now I know that I have 0.124 moles of carbon dioxide, and I have all of the other information that I needed for my ideal gas law in order to solve for the volume. So my ideal gas law again, PV equals nRT, trying to solve for the volume. So let's just get rid of my pressure term. So volume equals nRT divided by P. So we can substitute in all of the information that we have in order to solve. So 0.124 moles, 8.314 kilopascals liter moles Kelvin. And I ran out of room here, so I'm just going to put my temperature up here, but hopefully you can fit yours in a better spot. So 338 Kelvin over the 103.5 kilopascals. Okay, so sorry for this messy writing here. Let's see if we can follow this through. So again, I want to cancel out all my units to make sure that it all makes sense. So I have moles crossing with moles. I have Kelvin, don't forget about this guy, with Kelvin. I have kilopascals with kilopascals. I'm left with liters, which makes sense as I'm solving for my volume here. So if I plugged all of this in, I would find that the volume is 3.37 liters of carbon dioxide present here. So let's go back to our initial question, make sure our sig figs are all good. I should only be reporting 2 sig figs here, and that's from my temperature. So the volume actually equals 3.4 liters as my final answer for the volume of carbon dioxide being produced. Okay, as you're going through the homework for this section, you'll see that some of the questions are asking for the volume ratio. So just to prompt your memory, I want you to think about Avogadro's law. And remember that Avogadro stated, or that his law stated, that the number of moles is proportional to the volume of a gas. So if I see a doubling in moles, then I should see a doubling in that volume. So they're both proportional to that. So just keep that in mind as you're going through these homework questions tonight.